Assalamualaikum and good day everyone. So how are you for today? So I hope you're doing well at home while watching my videos. Okay, today we are going to proceed with a new chapter which is Laplace transform. Okay, as we know, Laplace transform can also be used to solve first order and second order linear differential equation. Okay, especially if we can't solve by using the previous method in chapter 3 or chapter 2. Okay, so you can use Laplace transform to solve that differential equation. Okay, but before you can solve by using Laplace transform, you have to know um, what is Laplace transform. Okay, so today we are going to discuss what is Laplace transform and how to find the Laplace transform by using table of Laplace transform. Okay, so basically this is the summary for chapter 4. Okay, so the first one is find the Laplace transform by using table of Laplace transform. Next, we will take a look at the properties of the Laplace transform. So here you have three properties: linearity, first shift, and also multiplying by Tn function. Okay. Next, we proceed with inverse Laplace transform by using table and also properties of inverse Laplace transform. Okay. For the properties of inverse Laplace transforms, it will cover linearity properties, first shift, and also rational function, or we'll call it partial fraction. Okay. Then only you can solve first order and second order linear differential equation. So I always ask my student to really master on this 4 subtopic, because you're going to use all this one to solve first order and second order linear differential equation. Okay, so as for today, we'll start with the easy one first, which is the first one. Okay, find the Laplace transform by using table of Laplace transform. Okay, so before you can use table of Laplace transform to solve Laplace transform, first you have to know what is Laplace transform. So by definition, Laplace transform is defined by, if you have a function ft, so the Laplace of ft is equals to fs. So basically, you are going to transfer from t domain to s domain. Okay, from ft to be fs, from gt to be gs. Okay, from yt to be ys. Okay, so you are going to transform this one into s domain by using the Laplace operator, which is this one. Okay, so function in terms of t function, you use Laplace, then you will have s function. Okay, that is basically how it works. So what is table of Laplace transform? This one. Okay, so this table will be used in this chapter, especially on finding the Laplace transform of the specific function that is given to you. Okay, so as you can see here, at the top here you have ft function, this one, and this is your fs. Okay, so for today we are going to take a look at this side first. Okay, just focus on the first two column. Okay, on how to find the Laplace transform of this function. Okay, so if you have a constant, this is your fs. Okay, and this one is for t to the power of n, where your n can be 1, 2, 3 and so on. Okay, for the third one, this is exponential function, this is sine and cos function, and this is sine hyperbolic and cos hyperbolic function. Okay, so see the difference here. For sine and cos, what is the difference here? So as you can see here, the numerator here, okay, where for the sine function you will have a over s squared plus a squared. So what is your a? Your constant here. Okay, whereby for cos function you will have s over s squared plus a squared. Okay, and what is the difference between sine and cos, and also sine hyperbolic and cos hyperbolic function? The difference is just the notation here, whereby for sine and cos we are use the summation here. Okay, so s squared plus a squared. Okay, but for hyperbolic function, the denominator here is s squared minus a squared. Okay, so now we will take a look at an example on how to find Laplace transform of a function t. Okay, so please refer to your notes in that module for you to get the questions. Okay, the first one. You were asked to use the table of Laplace transform to find the Laplace transform of this one. A is equals to, your ft is equals to 1 over 2. Okay, so you were asked to find the Laplace of 1 over 2. So here 1 over 2 is a constant, right? So take a look at this table of Laplace transform. Find on your left hand side which one refer to a constant. Okay, so this is a function t, this is exponent, this is trigonometric function, this is hyperbolic function. So a here is a constant. So if your ft is equals to a, your fs is equals to a over s. So therefore you will have Laplace of 1 over 2 is equals to 1 over 2s. Okay, how I get this one? So basically you have Laplace of a is equals to a over s. So in this case your a is equals to 1 over 2. So that's why when I substitute 1 over 2 here, you will have 1 over 2s. Okay, this is the simplest one. Okay, whereby your function is a constant, your ft is a constant. Okay, so next, b. What if your ft is equals to t squared? Okay, so now you have to take a look at this one. Okay, t squared. So what is the general function as referred to this table? So obviously you have to use this one, t to the power of n, isn't it? Because you have here t squared. So you are using Laplace of t to the power of n is equals to n factorial over s n plus 1. Okay, I write it here. Laplace of tn is equals to n factorial over s n plus 1. Okay, so now what is your n here? Your n is equals to 2. Where did I get the value of 2? It's from here, the power of t. Okay, so you know that your n is equals to 2. But what you need here is n factorial. So you will have to find 2 factorial, which is equals to 2. So how to get the factorial? So your calculator, by using calculator, so 2 factorial. So shift this one. So 2 factorial is equals to 2. Okay. So if you have 4 factorial, then you will have 24. Okay. So 2 factorial is equals to 2. So therefore, Laplace of t squared is equals to n factorial, which is 2 factorial 2 over s n plus 1. Since your n is equals to 2, so n plus 1 is equals to 3. Okay. Okay, so now the next one, exponential function. Okay, so let's say u of t is equals to exponent 1 over 2 t. Okay, let's say u of t is equals to exponent 1 over 2 t. So by using table of Laplace transform, so you have to refer to the exponential function. If you have your ft in the form of exponential function, your fs is equals to 1 over s minus a. So what is a here? Your a refer to the power of the exponential function. Okay. So Laplace of, I write it here, okay. So Laplace of exponent at is equals to 1 over s minus e. Okay. So when you compare the general one with what you have for your ft, you know that your a is equals to 1 over 2. Okay. So you know that your a is equals to 1 over 2. So therefore, Laplace of exponent 1 over 2t is equals to 1 over s minus, so a is equals to 1 over 2. Or you can simplify this one, then you will have 2 over 2s minus 1. Okay, so how to simplify this one? So you are using, so how to simplify this one until you get this function. But it is okay if you stop here, but if you want to make it more nicely in mathematic way of write the function, so this is the last answer lah. Okay, but if you stop here, we can also accept your answer. Okay, so how I get from here to here? So what I did is, first, see at the denominator here you have s minus 1 over 2. So when you simplify this one, actually you will have 2s minus 1 over 2, isn't it? Because this one is s over 1. So times by 2. Then you will have this one. Okay? So you have here 1 divided by s minus 1 over 2, which is this one. So if you change this one to multiply, so you will have 2 over 2s minus 1, this answer. Okay, so we already take a look at the first three. So if your ft is a constant, your ft is t to the power of n, and the next one is if your ft is equals to exponential function. So now we proceed with what is your fs if your ft is a trigonometric function. Okay, so let's say you have ft is equals to cos 2t. Okay, so generally if your ft is cos at, so your fs is equals to s over s squared plus e squared. Okay, so Laplace of cos at is equals to s over s squared plus a squared. So you have to know what is your a. Okay, so by comparing this one and what you have here, you know that your a is equals to 2. Okay, your a is equals to 2. So therefore Laplace of cos 2t is equals to s over s squared plus, so a squared, which is equals to 4. Okay, as simple as that. So let's consider if your ft is equals to sine function, sine 2t. Okay, as I told you before, the only difference between cos function and sine function is that for cos function you have s for the numerator, but for the sine function you will have a over s squared plus e squared. So for the numerator here you have a constant. So by comparing your ft that you have with the general one, you know that your a is equals to 2. Okay, so therefore Laplace of sine 2t is equals to, so a is equals to 2, so you will have 2 over s squared plus e squared, which is equals to 4. Okay, the only difference for the trigonometric function is the numerator part. Okay, where for the cos function you will have s, and for the sine function you will have a constant a. So what is your a depends on what is your ft. Okay, the argument for sine. Okay, so next we take a look at the hyperbolic function. If you have sine hyperbolic and also cos hyperbolic function. Okay, so since it is just the same thing, so let's just take a look at this example. So let's say your ft is equals to cos hyperbolic 3t. Okay, so by using table of Laplace transform, when you have a hyperbolic function, your fs is equals to s over s squared minus e squared. So you know that Laplace of cos hyperbolic at is equals to s over s squared minus e squared. Okay, so by comparing your ft with the general one, you know that your a is equals to 3. Okay, so your a is equals to 3, so therefore your Laplace of hyperbolic cos h 3t is equals to s over s squared minus a squared. So 3 squared is equals to 9. Okay, so take a look at this one. When you have your ft cos function and also hyperbolic function cos. okay, cos function, hyperbolic function, okay, for cos hyperbolic and also cos function. So the only difference is the sign here, okay, whereby for trigonometric function, cos function, you will have plus sign, but for hyperbolic function cos, you will have minus sign, okay. Okay, what if your ft is equals to 0? So what is your fs if your ft is equals to 0? Okay, 0 is a constant, right? So you have to use the first one, this one. So Laplace of 0 equals to 0. Why 0? 0 over s is equals to 0. So Laplace of 0 is equals to 0. Okay. So next one, if you have your ft is equals to exponent negative 3t. So take a look at the table of Laplace transform. Which one are you going to use? So since this is an exponential function, so you have to refer to the exponential function here. Okay. So again, for exponential function, we have to know what is your a. So as you know here, as you can see here, your a is equals to negative 3. But be careful. Okay. Here, as we discussed earlier, the general for exponent is 1 over s minus a. Okay. But now what you have is your a is a negative function. Okay. So therefore, your Laplace transform of exponent negative 3t is equals to 1 over s minus a. What is your a? Negative 3. Okay, so you will have 1 over s plus 3. Okay, so just be careful with the plus minus sign. Okay, because generally for exponential you will have a negative sign here, s minus a, but your a here is positive. So if you have your a negative, then you will have this one, s plus a. Okay. Okay, so the next one, if your ft is equals to sine 3t. Okay, so first write down what is the general for sine function. Okay, so if you have Laplace of sine at, then you will have a over s squared plus a squared. Okay, so by comparing the general one with what you have here, you know that your a is equals to sec 3. So your a squared is equals to sec 3 squared, which is equals to 3. So therefore, Laplace of sine sec 3t is equals to, so what is your a? Sec 3 over s squared plus 3. Okay. So the next one, your ft is equals to t to the power of 5. Okay. So this is t to the power of n function. So generally you will have Laplace of tn is equals to n factorial over s n plus 1. So what is your n in this case? Your n is equals to 5. Okay, So 5 factorial will give you 120. Okay, so therefore Laplace of t to the power of 5 is equals to n factorial, which is 5 factorial 120 over s n plus 1, so s to the power of 6. Okay, so the last two. So let's consider your ft is equals to cos hyperbolic 1 over 2t. Okay, so what is the general for this one? Laplace of cos hyperbolic at is equals to s over s squared minus a squared. Okay, so what is your a in this case? Your a is equals to 1 over 2. So your a squared is equals to 1 over 4. Okay, so therefore Laplace of cos hyperbolic 1 over 2t is equals to s over s squared minus 1 over 4. Be careful, this one is a squared, nothing to do with the negative sign. Okay, a squared. So if your a is equals to 1 over 2, then you will have your a squared is equals to 1 over 4. Okay, so if you simplify this one by using the same technique as the previous questions, so you will end up with 4s over 4s squared minus 1. Okay, so please try to do until you get this answer. Okay, so the last one is if your ft is equals to cos kt, where your a here is equals to k. Okay, don't worry, just proceed. Okay, so Laplace of cos kt is equals to s over s squared plus k squared. Okay, because your a is equals to k. Okay, so basically this is how we find a Laplace transform by using table of Laplace transform. Okay, so try to do the exercise in the textbooks, and we will proceed with properties of Laplace transform for the next video. So if you have any problem regarding this one and how to find the Laplace transform by using table, so please ask me either through Moodle or WhatsApp. Okay, because this is very important. Okay, later on when we discuss on properties of Laplace transform, we also need to use this one. Okay, so please make sure you really understand. I had shown to you many example a until L, so I hope you are able to understand. Okay, but if you still don't understand, please ask me so that I can guide you. Okay, so I shall see you in my next video for the properties of Laplace transform. Thank you.